All right, we're here in the middle of page 1. We'll see how quickly we can get through both. Maybe we can fit both in this second video. So either way, we're in 2.4, page 1b. We'll see if we need a C, but we'll take that as it comes. So we are solving for a specified variable. So there's more than one variable that we see at the beginning of the equation. We're going to use our same steps, but instead of solving and expecting a numerical single number answer, we are going to just have a rearranged formula. So there's still going to be variables involved in our answer. Right now we have, on number 26, we have x plus by equals c. We're going to rearrange that for y. So our goal here is to get to y equals, and all the rest of the equation is on the right side. Okay, but still an equivalent, same idea, but we just need to undo everything that's happening to y and get it all on the other side. Okay, so we use the same steps as before. First we look to see if there's any parentheses, and we make sure that all like terms have been combined on either side of the equal sign, and we also make sure that the variable we're interested in this case y, has picked a side. And all of these are done for us. We don't have to worry about any of that. We're just going to jump right into where we ask ourselves, what is happening to the y variable? In other words, if we plugged in a value for y right here, order of operations would have us do what? And then what? So in this case, it would get multiplied by b, and then whatever ax is, that would get added to it. Okay, so let's go ahead and write down those steps. If you put in something for the y value, it would get multiplied by b, capital B. The second thing that would happen is that ax would get added to it. Okay, and we don't know what b is right now. We don't know what ax is, and that is the point. The point is to start getting comfortable moving things around without knowing their value, so that we do the same steps we would do with numbers, but now we're applying it to the algebra, to the variables, to the mystery values. Okay, so the steps don't change. And again, if the steps are unfamiliar to you, or you have not put enough practice time in and you're feeling unsure, go back to section 2.3, pick out a bunch of equations and work those until you're really solid on the steps. Okay, and again, what we're doing here is, for those of you who look at this and go, I have no idea where to start, these steps will tell you exactly what you need to do. So what's happening to y? Well, it's getting multiplied by b, and then ax is getting added. Or if you wanted to write that in more of a visual timeline, where we looked kind of left to right across the page here, you would say y times b plus ax. Okay, just kind of a way to read that across, not using as many words, more of a visual look to it. So now this will tell us what's happening to y. We want to undo everything that's happening to y so that we can solve the equation for y, make y equal the rest of everything we see. So we do that by reversing the order and using opposite operations. So our last step, step 2, would become step 1. Our first step would become our second step, reversing that order, just going up the list, and everything becomes the opposite operation. Add becomes subtract, multiply becomes divide. This should sound really familiar because it's what we did over and over and over again in 2-1, 2-2, 2-3. Okay. Or if you were to use the timeline, we would go from right to left on this timeline. The first thing we come to is plus ax. We'll make that a minus ax. The next thing we come to is times b. We'll make that divide by b. And we'll just go from right to left to tell us what to do. So the first thing is to subtract ax. Both of these versions, you don't have to do both. You pick one that's makes the most sense to you. And that tells us exactly what to do first. We're going to subtract ax from both sides. That's going to be critical, is that you do it to both sides. So I'm going to subtract ax from both sides, and I'm going to actually rewrite this to give myself a little bit more space. Remembering our goal here, our goal is to get y by itself. So I'm going to start by subtracting ax from both sides. This is where it feels different. Everything is kind of felt the same. We have letters instead of numbers, but right here it does cancel like we're used to. We're left with just the by on the left side. But over here on the right side, we're used to these being two values, two numbers, and they combine together for a single value. They aren't going to combine. We don't know the value. There's still a mystery. It's still in algebra form. So we write it just like we would read it, c minus ax, c minus a times x. Okay, and then go to our list. We accomplished that first piece. We took care of that first step. The second step, depending on which list or visual aid you're using here, says second step, divide by b. As we go right to left here, the second thing we come across is divide by b. So we divide both sides, the whole side, by b. And so our answer is y equals c minus a times x, the whole thing over b. And we can check that back in the original, okay? Now the checking feels a little funky. I want you to really utilize the back of the book to be able to double check your answer here. But go with the original equation. It was a times x plus b times y. Since we're solving for y, that's what I'm going to plug into. So I'm going to take my answer here and put it in, and I'm wondering, will I get a true statement? Will I get c out of this? So I start with c minus ax, the whole thing over b. Okay, I'm running out of space here, so I'm just going to do this real quickly, kind of shorthand here. This is like b over 1, so the b on top and the b on the bottom of multiplying fractions, they cancel each other. That'll leave me ax plus, no parentheses needed now, the multiplication's done, c minus ax. My question is, does that equal c? And indeed, the ax minus ax are going to cancel each other, because you could use commutative and associative, move these around, okay? And then you'd be just left with c equals c, which is a true statement. So my equation that I rearranged checks, which means that when I solve ax plus by equals c for y, I rearrange this equation so y is by itself. What I get is y equals c minus ax over b. Okay, so we're going to pause the video and we'll do the next one down at the bottom of the page as its own separate video. Okay, I will see you there. Good job.